Hello and welcome back to Deep Dive AI on AI, the show where we explore the latest trends and technologies shaping the future of enterprise. Today we have an extra special panel of experts to guide us through what might be the most profound shift in corporate architecture since the advent of personal computing. We're talking about the new AI tier, the rise of agent-based systems within the enterprise, and how organizations can transform their legacy environments into fully autonomous, intelligent ecosystems. I'm thrilled to introduce our three guests. Shimmer, a veteran in enterprise architecture and generative AI, with decades of experience helping global organizations design large-scale systems. Arjun, an experienced CXO who has led multiple digital transformations and knows exactly what it takes to prepare your workforce and organization for such a massive shift. Jess, an AI agent subject matter expert who has been developing agentic frameworks for large enterprises, enabling specialized AI entities to coordinate, orchestrate, and deliver business value at scale. We have a lot to cover. Everything from the conceptual AI agent fabric to the nitty-gritty details of specialized roles, from data age intelligence to best practices for implementing this new AI tier. So let's jump right in. Shimmer, I know you've been working in enterprise architecture for a long time. When we look at the images we have in front of us, we see a progression from islands of automation in various enterprise systems, ERP, CRM, HR, and we move into a future state that's described as an AI agent fabric. Could you kick us off by explaining this transition and what it means for enterprise architecture?
Shar, absolutely. Thank you for having me. In traditional enterprises, we often see that each department, sales, finance, HR, bought or built its own systems. So you have a CRM for sales, an ERP for finance, an HR system for managing employees. Over time, these became islands of automation because while each might be efficient in its own domain, they only partially connect with each other. Now, with the rise of AI, particularly large language models and agent-based frameworks, we're seeing a shift from these disconnected islands to a kind of fabric that overlays the entire enterprise. Instead of thinking, I log into CRM for one thing, ERP for another, you have AI agents that know how to talk to all those systems on your behalf. And more importantly, they can talk to each other, orchestrating processes that span multiple departments. It's like going from a patchwork of highways, each with different tolls and different rules, to a new automated traffic system that can route you seamlessly. The AI agent fabric is the software equivalent, specialized AI workers, agents that handle tasks, understand context, and share intelligence across the organization.
Let me pivot to Arjun. As a CXO, you've witnessed the entire evolution of enterprise tech. Mainframes, client-server, web, mobile, cloud, and now AI. From a leadership standpoint, what's the significance of introducing what these diagrams call the AI tier?
Thanks. It's great to be here. The introduction of an AI tier is incredibly significant because it's not just another technology wave. It's a fundamental rethinking of how work gets done. Historically, even with automation, you still needed people in the loop to interpret data, navigate multiple systems, and make sense of the complexity. With this new AI tier, we're talking about agents that can truly understand and act on behalf of users. They can interpret natural language, orchestrate complex workflows, analyze data at scale, and even propose improvements or generate insights that humans might miss. From a C-suite perspective, that means you can shift from a model where people are constantly toggling between systems and fighting with data silos to a model where you have an overarching intelligence layer. That layer ensures that if you, as a CFO, ask a question about last quarter's P&L with specific detail on region and product mix, the system itself pieces everything together. You don't have to know which system stores what data. Your AI agent handles it. That has profound implications for speed, agility, and strategic decision-making.
This notion of specialized AI workers is fascinating. Jess, you've been heavily involved in building these agentic frameworks. The diagram we're looking at references something called the brain, which seems to be an overarching AI orchestration layer, and then specialized agents, each focusing on a domain, CRM, ERP, HR, etc. Could you talk more about how those pieces fit together?
Sure thing. The best way to think about it is to imagine a conductor in an orchestra. The brain is like the conductor, understanding the user's intent, keeping track of context, deciding which section of the orchestra, i.e., which specialized agents, should play next. The specialized agents, in turn, are like sections of the orchestra: woodwinds, brass, percussion, each good at a particular type of task. One agent might be specialized in CRM tasks, reading or updating customer records, logging interactions, analyzing lead data. Another agent focuses on ERP, dealing with financials, supply chain, inventory. A third is specialized in HR processes, like payroll or benefits administration. When you say, hey, I need a forecast that includes both sales projections and the cost of hiring new staff next quarter, the brain agent breaks that request down. The CRM agent collects relevant sales data. The HR agent gathers hiring data, and then maybe an analytics agent merges it all. Finally, the brain brings the results together into a coherent response for the user. That's the AI agent fabric in action.
Let's ground this in a concrete scenario. Suppose we have a manufacturing company that wants to streamline their order-to-cash process. Traditionally, that touches CRM, ERP, finance, sometimes a separate inventory management system. Shimmer, how would an AI agent fabric tackle that?
Great example. Order to cash can be quite complex, often spanning multiple systems. You have CRM for capturing the order, ERP for managing the financial transactions, an inventory system to check stock, a shipping system to handle logistics, and so on. In an AI agent fabric scenario, you'd have specialized agents for each domain. The user or an automated trigger might initiate something like process order 12345 for customer X. The brain orchestrates everything. 1. The agents the customer details, cross-checks if the order is valid and meets the contractual terms. 2. The inventory agent checks if the product is in stock. The ERP agent calculates the cost, tax, and final invoice details. Possibly a shipping logistics agent schedules delivery. 5. A finance agent initiates the payment process, sends an invoice, and updates the general ledger accordingly. All these steps happen behind the scenes, automatically. If something goes wrong, like low stock, the AI agent can raise a flag or even automatically escalate to procurement if that's part of the company's rules. Essentially, what used to be a manual or at best partially automated handoff between departments now becomes a seamless chain of agent-driven processes.
Arjun, you mentioned last time about the importance of roles and responsibilities for this new AI world. Could you elaborate if an organization wants to adopt this AI tier? Who do they need on board?
Yes, skills are paramount. Organizations can't just say, we'll install an AI tool and be done. They need new roles such as 1. Agent developer, agent designer, someone who knows how to create, configure, and maintain these specialized agents. It's not just coding, it's also about understanding domain logic, data flows, and how to integrate with existing systems. 2. Prompt engineer, conversation designer. Because the user experience is often through natural language, these folks craft how the AI interacts with humans. They figure out the best ways to phrase prompts, handle edge cases, and guide the AI to produce valuable outputs. 3. AI product owner, or AI business analyst. This person is the liaison between business needs and AI capabilities. They define what the agents should do, measure success, track ROI, and prioritize features or improvements. 4. Data steward. This is key for ensuring data quality, compliance, ethical guidelines, and accountability. They oversee how data is accessed by the AI, how results are audited, and how to mitigate biases or compliance risks. Change management lead, organizational coach. We're talking about a new way of working. People who are used to opening a particular system or emailing a colleague for data might be hesitant. A good change management leader helps employees adapt, trains them on new tools, and addresses cultural barriers. So it's a mix of technical and organizational roles. You want a cross-functional team to handle not just the tech stack, but also the people and processes that go with it.
Let's refer to another image we have: AI-driven enterprise architecture, components, and interactions. We see an AI orchestration layer, various agents, general AI agents, task-specific agents, communication agents, analytics agents, and so forth, and then these back-end systems like databases, CRM, ERP, financial systems. Jess, can you walk us through how these components interrelate?
Absolutely. That diagram essentially breaks down the layers. AI orchestration layer, copilot, and AI agents. This is the top-level intelligence, often called the brain, that listens to user requests, interprets them using language models, and decides which specialized agents to call. General AI agents, language model processing, reasoning. Think GPT-like services, or any large language model that can parse natural language, summarize content, or reason about queries. They're good for broad tasks, but might not know the intricacies of your ERP's data schema. Productivity agents, Excel with Python, Word, Teams with Copilot agents. These handle common office tasks or productivity workflows. For instance, automatically generating a monthly report in Excel, drafting policy documents in Word, or summarizing chat transcripts in Teams. Task-specific agents. Workflow, planning. If you have a well-defined workflow, say approving a purchase request, these agents handle that workflow logic, including branching conditions and any necessary user approvals. Specialist app agents, CRM, ERP, finance. These are the domain experts. They know exactly how to interface with your CRM or ERP, including data fields, forms, integration points, and validation rules. Core app agents, shared tools, core reasoning functions. Some tasks are universal, like authentication, logging, or cross-cutting concerns. Think of them as utilities that any agent can call. Communication aid chat. They handle inbound and outbound communications, whether it's drafting an email to a customer or responding to an internal Slack or Teams message. Analytics agents, Power BI, etc. They generate charts, dashboards, or data visualizations on request. They might integrate with data lakes or warehouses, and the orchestration layer can ask them to produce a certain chart or forecast. External services integration agents. If you rely on external APIs, like shipping providers, payment gateways, or third-party data services, these specialized agents handle those integrations, ensuring you can incorporate outside data or trigger external actions. Underneath all that, you have your multiple back-end systems: databases, data lakes, CRM systems, ERP systems, financial systems. The agents know how to do CRUD, create, read, update, delete on these systems, but the orchestration layer ensures everything is done securely and logically.
In many organizations, data is spread out over on-premises systems, cloud environments, or sometimes third-party SaaS solutions. Shimmer, how does data flow in this architecture, and how do we ensure security?
Excellent question. One of the main reasons this new AI tier is so compelling is that we can build secure data pipelines that the AI agents use. Instead of having each user log into multiple systems and rummage around, the agents become the gatekeepers, using OAuth or other secure methods to authenticate and retrieve data only if the user or the automated workflow has the correct permissions. A typical data flow might look like this. 1. A user types a query. Show me the pipeline of new leads this month in the CRM. 2. The AI orchestration layer checks the user's identity and role, maybe using Azure Active Directory or any other identity provider. 3. If the user is authorized to view CRM lead data, the orchestration layer calls the CRM specialist agent with the relevant parameters. 4. The CRM specialist agent securely queries the CRM system's API or database, retrieving only the data the user is allowed to see. 5. It returns the data to the orchestrator, which might call a language model or an analytics agent to transform it into a summary or chart. 6. The final response is presented back to the user. Throughout the process, we can log what data was accessed, by which agent, and for which user request. This logging is critical for audits, compliance, and governance. With an AI agent fabric, ironically, you can often achieve more robust security because you centralize the logic for data access and permissions, rather than distributing them in 1,000 different places.
Let's turn to Arjun. From a business standpoint, how do you measure ROI on this AI Agent Fabric initiative? It sounds transformative, but how do we justify the investment?
Great question. Often, the immediate ROI comes from 1. Time savings. Tasks that took hours or days, like manual data entry, searching for information across systems, reconciling spreadsheets, now happen in seconds. 2. Reduction in errors. Humans inevitably make mistakes when rekeying data or missing critical steps in a process. Agents follow well-defined rules meticulously, which reduces costly errors. 3. Better insights. Because AI can parse data at scale and find patterns, you might discover new revenue opportunities, cost reductions, or risk mitigation strategies that were invisible before. 4. Employee satisfaction. This is intangible but crucial. When employees don't have to wrestle with outdated systems, they're more engaged, productive, and can focus on higher-value tasks. We typically track metrics like reduced cycle times, order-to-cash cycle time, for instance, reduction in manual labor hours, improvement in data quality, and speed of decision-making. Over time, as the system matures, you can set more advanced KPIs, like measuring how many business processes are 95% automated or how many new insights the AI surfaces that lead to actual revenue gains. A direct financial ROI might show up within 12 to 24 months for large enterprises, especially if you start with use cases that have clear, quantifiable pain points. That said, it's also a strategic play. You're building the foundation for the next decade of AI-driven operations, which can be a competitive differentiator.
One of the images references empowering your people, the future-ready workforce, showing a shift from current skills, like manual processes, data entry, to future skills like AI interaction, automated agents, process optimization, AI-driven tools, data age intelligence. Jess, could you define data age intelligence for us and how it fits into workforce transformation?
Absolutely. Data age intelligence is a term we use to describe how AI agents can not just passively analyze data, but actively interact with it, derive insights, and even take autonomous actions. In a traditional data analytics environment, a human analyst logs into a BI tool, selects some filters, runs queries, interprets results, and then decides what to do next. With data age intelligence, the AI agent itself can do all those steps. It can look for anomalies, correlations, or patterns. It can hypothesize reasons behind these patterns, maybe cross-reference them with data from other departments, and then either present a recommendation to a human or trigger an automated workflow. For the workforce, that means employees shift from being the data wrangler to being the data strategist. Instead of, I have to figure out how to run this query, it's the agent ran these queries and found these interesting trends. Let's discuss how we can leverage them for business goals. This elevates employees to more decision-making and strategic thinking roles, leaving the grunt work to AI.
Shimmer, we also have a comparison chart between traditional data analysis and data age intelligence. It lists features like driver, process, speed, scalability, insights, actionability, adaptability. Can you elaborate on that?
Sure. Traditional data analysis is typically human analyst-driven. You form a hypothesis, gather data, run queries, visualize in a dashboard, interpret it, and then you might share the results in a meeting or email. The process is somewhat manual and can be slow, hours, days, or sometimes weeks, especially if data is spread out in many silos. Data age intelligence flips that. The driver is now an AI agent that can continuously monitor data streams, pick up patterns or anomalies, and react almost instantly. Instead of a manual, hypothesis-driven approach, it's automated, data-driven, and goal-oriented. For instance, if your goal is to maximize sales in a certain region, the AI might keep scanning real-time sales data, competitor pricing, and supply chain constraints, then make suggestions on pricing strategies or inventory placement. The speed is obviously much faster because the AI doesn't need to wait for a scheduled human analysis session. Scalability is higher because the AI can track hundreds of metrics simultaneously without overload. Insights can be deeper or more unexpected because the AI can connect dots across datasets that a single human might not notice. It's also more actionable because once the agent finds a pattern, it can directly take action, like reordering inventory or adjusting marketing campaigns, subject to the guardrails set by the business. Finally, adaptability is key. Agentic systems can learn from new data. If the environment changes, like supply chain disruptions or market shifts, The AI can adapt the logic or the prompts in near real time without needing a human to reprogram everything.
Arjun, from a leadership perspective, how do you handle the cultural or psychological barriers to adopting AI agents? People might worry about job displacement or the complexity of dealing with AI.
Culture is always the biggest barrier. I often say technology is the easy part, people are the hard part. We address it with a few strategies. 1. Transparent communication. We emphasize that these AI agents are here to augment human roles, not replace them. They take away the tedium, like copying data from one system to another, so employees can focus on creativity, relationship building, strategy, or problem solving. 2. Skill uplift programs. We invest in training. Show employees how to converse with an AI agent, how to interpret AI-driven insights, how to quickly verify or provide feedback to the system. That can be done via short e-learning modules, in-person workshops, or brown bag sessions. 3. Early wins. We pick a pilot project with a very visible pain point. Maybe it's automating a monthly report that used to consume 10 hours of an analyst's time. Once employees see how quickly the AI can do it, and how it doesn't threaten the analyst, but actually frees them to do more interesting work, they become more open to adopting AI in other areas. 4. AI champions. We appoint champions or ambassadors in different departments. These are people who are excited about the technology and can help their peers adopt it. They provide a friendly face to ask questions or troubleshoot issues. 5. Set realistic expectations. This is crucial. AI won't be perfect on day one. It might make mistakes or require some training. Being honest about the iterative process and framing it as a journey, not an overnight switch, helps manage skepticism.
Jess, as these agents evolve, how do we continuously improve them? Is there an M operations angle here?
Absolutely. Agentic systems rely heavily on AI models, whether they're language models, recommendation engines, or predictive analytics. MLOps ensures that these models are versioned, tested, and deployed with proper governance. For instance, if you discover your AI agent for CRM is making suboptimal recommendations, maybe it's missing certain leads or misclassifying them, your data science team can roll out an updated model. MLOps pipelines handle the retraining, model validation, A/B testing, and safe deployment. So the agent always has the best possible logic under the hood. Moreover, feedback loops are integral. When users reject or correct an AI suggestion, that data can feed back into model retraining. Over time, the agent gets smarter, reduces errors, and aligns more closely with business goals. The key is to treat AI not as a static piece of software, but as a living system that learns from every interaction.
Another concept in the diagram references intra-org versus inter-org. Shimmer, does that mean these agents can extend beyond the boundaries of a single company?
Yes, that's a very exciting prospect. Imagine a scenario where your CRM agent can talk to your distributor's logistics agent to coordinate shipping schedules, or your finance agent can talk to a bank's lending agent to negotiate credit terms. The idea is that as more companies adopt AI agent fabrics, they can securely expose certain agent endpoints to their trusted partners or suppliers. We're not fully there yet in many industries, but the potential is huge. Instead of sending emails back and forth about purchase orders or shipping updates, these AI agents can communicate in real time, verifying availability, price changes, delivery times, all in a secure, permissioned way. This essentially automates B2B interactions that currently rely on manual or semi-automated processes.
Let's try to distill all this into practical steps. Arjun, if I'm a mid-sized enterprise CFO or CIO listening thinking, yes, I want to do this, how do I begin?
I'd suggest a phased approach. 1. Education and alignment. Start by educating your leadership team on what AI agents can do. Align on a vision. Where do you most urgently need automation or intelligence? 2. Identify high-value use cases. Don't try to transform everything at once. Pick a couple of processes that are both critical to your business and have a clear pain point, like the monthly financial closing or a complicated customer service workflow. 3. Assemble a cross-functional team. Include IT, data specialists, business analysts, and a few forward-thinking employees from the target department. If possible, bring in an external advisor who's done this before. 4. Build a proof of concept. Use existing AI frameworks, agentic platforms, or cloud services that can stand up quickly. Show a working demo that solves a small but meaningful problem. 5. Iterate and learn. Gather feedback, measure results, refine. If the POC is successful, scale it to a pilot with more users or bigger datasets. 6. Formalize the AI COE, Center of Excellence. If your pilot goes well, form a Center of Excellence responsible for governance, best practices, and training across the organization. 7. Plan for continuous improvement. Have an MLOps pipeline, ongoing training for staff, and a backlog of new use cases to tackle. Over time, the AI tier becomes an integral part of your enterprise architecture.
Jess, I noticed mention of productivity agents in the diagram, like Excel with Python Word and Teams with Copilot agents. Could you talk about the synergy between enterprise AI agents and day-to-day productivity tools?
Absolutely. This is one of the biggest levers for adoption because employees already live inside tools like Excel, Word, Teams, or Slack. If we embed an AI agent right there, like a Teams bot or a Copilot plugin for Word, employees don't have to learn a new interface. They can just type, draft a summary of last month's sales performance, or generate a chart from these columns of data, and the AI does it. Imagine that your ERP agent finds an anomaly in last month's sales data. That agent can automatically send a Teams message to the sales manager's channel saying, "Hey, I've noticed a spike in returned products in the Midwest. Would you like me to create a pivot table in Excel with more details?" If the manager says yes, the agent does it. This synergy dramatically reduces friction. People don't leave the environment they're comfortable with, and the AI is right at their fingertips, guiding them or taking on tasks as needed.
One concern might be that once we have dozens of agents interacting, it could become quite complex, like a spaghetti network of AI calls. Shimmer, how do we maintain clarity and control in such a dynamic environment?
This is where architectural discipline is crucial. We generally recommend having a single orchestration layer. That's the brain, which acts as a gateway for user requests and also mediates agent-to-agent communication if needed. Clear boundaries. Each specialized agent should have a well-defined domain. The CRM agent deals with CRM tasks, the finance agent deals with finance tasks, etc., to avoid overlap or confusion. Auditable workflows. Even if it's AI-driven, you want a record of which agent did what, why, and when. This might involve storing logs in a central system with an easy way to trace a transaction or query across multiple agents. Human-in-the-loop mechanisms. For certain critical or high-risk tasks, you might require a human to approve or verify the AI's action before it commits. That ensures you don't lose ultimate control. By designing with these best practices in mind, you can handle the complexity gracefully. Instead of a chaotic web, you end up with a managed ecosystem where each agent has a clear role.
Jess, you've talked before about frameworks like Swarm, referencing multiple agents that can spontaneously coordinate. Could you explain what that means and how it differs from a simple orchestrator model?
Of course. The orchestrator model is more top-down. You have a brain agent that coordinates the rest. Swarm or agentic frameworks with peer-to-peer coordination allow multiple agents to negotiate or collaborate without a single controlling entity. They can, for instance, elect a leader or exchange data asynchronously until they converge on a solution. This can be powerful for highly decentralized or large-scale scenarios, like supply chain networks involving hundreds of partners. Each agent might represent a node in the supply chain, and together they work out optimal shipping routes, inventory levels, or production schedules. The advantage is resilience and scalability. The challenge is ensuring that the swarm doesn't devolve into chaos or produce conflicting actions. Some advanced organizations explore hybrid models. They keep a top-level orchestrator for broad direction, but allow specialized swarms among certain subsets of agents for local optimization. It's a fascinating area of AI research and can be particularly potent as networks grow in complexity.
Arjun, from a business standpoint, how do you decide whether to expand horizontally, adding more departments or lines of business to your AI tier, or vertically, deepening capabilities in a single domain?
That's a strategic call. If you have a mission-critical process like supply chain management that's already generating lots of ROI in one domain, you might want to go deeper. Add forecasting agents, real-time IoT data agents, advanced analytics, etc. That's a vertical expansion. On the other hand, if you see that multiple departments could benefit from the same framework, like a universal agent approach that handles approvals, document generation, or scheduling, then you go horizontal. For instance, after successfully automating your finance workflows, you might replicate the approach for HR or sales. In practice, you might do both over time, but it's wise to prioritize based on business impact. Evaluate which expansions yield the quickest or largest return and plan your roadmap accordingly. The advantage of an agentic architecture is that it's modular, so you can easily add new agents or new integrations without redesigning everything from scratch.
Let's wrap up by looking to the future. Shimmer, what are some emerging trends in enterprise AI architecture that you see coming in the next 2 to 3 years?
I'd highlight 3 big ones. 1. Multimodal agents. Beyond text, these agents can handle images, voice, and possibly even video. For instance, an agent that can read a schematic, interpret its contents, and then update a product design system. 2. Ethical and regulatory AI. As governments worldwide pass regulations on AI transparency and fairness, enterprises will need more robust frameworks to ensure agents comply with data protection laws, bias mitigation, and explainability requirements. Cross-company AI networks. We touched on interorganizational agent interactions. I think we'll see more large consortiums or supply chain alliances adopting a standardized agent protocol, enabling truly seamless B2B automation.
All right, we're close to the end of our time. Let's do a quick summary from each of you. Arjun, maybe we can start with you. What's your final word for business leaders?
In short, don't wait. The AI tier is here, and ignoring it risks losing competitive ground. Start small, pick clear use cases, demonstrate wins, and build from there. Also, invest in people, skills, change management, governance, and keep an open mind. The potential productivity gains are enormous, but it requires a shift in mindset.
Excellent. Jess, your closing thoughts?
For the technologists and developers out there, building an AI agent fabric can be a blast. There's so much room for creativity. Just remember the fundamentals. Design each agent with a clear purpose, maintain good orchestration and logging, and always think about user experience. If you get the fundamentals right, you can scale to some really sophisticated scenarios, like swarm-based optimization or advanced data age intelligence. The future is bright, so keep experimenting and iterating.
Perfect. Shimmer, take us home with your final summary.
Enterprise architecture is evolving from static layers of applications to a fluid tapestry of AI agents that talk, reason, and automate across organizational silos. It's a profound shift reminiscent of the move from mainframes to client-server or from on-prem to cloud, but it's arguably even bigger because it fundamentally changes how humans interact with technology. My advice, approach it methodically, but also with ambition. The organizations that get this right will unlock new levels of agility, efficiency, and innovation. Thanks for having me. This was a lot of fun.
That's all we have time for today on Deep Dive AI on AI. We hope this conversation has given you a thorough understanding of the AI tier concept, the role of an AI agent fabric, the importance of specialized and orchestrated agents, and how crucial it is to invest in your workforce's future power skills. Whether you're a small business looking to level up your processes or a global enterprise wanting to build the next generation of integrated systems, the message is clear. The future is agentic, connected, and intelligent. Thanks again to Shimmer, Arjun, and Jess for sharing their insights, and thank you all for tuning in. Join us next time as we continue exploring cutting-edge AI innovations. Until then, Stay curious and keep diving deep.